This is Mr. Beck Does Your Homework. This is physics homework number 11, questions number 4 and 5. It starts off, a car is traveling at 54.4 kilometers per hour. I'm not going to go any further than that because I know that 54.4 is not going to fit into any of my equations because it's that many kilometers per hour. And I can't work in kilometers per hour. I need to work in meters per second. So I'm going to have to convert. I know that 1,000 meters is the same as 1 kilometer. That'll allow kilometers to cancel out. I know that in order to get hours to seconds, I know that 1 hour is 60 minutes and 1 minute is 60 seconds. And that way minutes cancels out and hours cancels out, and I'm left with 54 times 1,000 divided by 60 will give me so many meters per second. Now, if you want to see a shortcut here, I've got 1,000 on the top and I've got 60 and 60 on the bottom. That's 1,000 over 3,600, or 1 over 3.6. Now, this is just not really necessary to know, but kilometers per hour divided by 3.6 gives you meters per second. All right, now that we've converted, a car is traveling at this speed on a flat highway. If the coefficient of kinetic friction between the tires on the road, between the road and the tires on a rainy day is 0.178, what is the minimum distance needed for the car to stop? Answer in units of meters. Well, this is a two-part question. One part of it is a equations of motion question. The other part is going to be a coefficient of friction question. So the first thing I know is the coefficient of kinetic friction is 0.178. So I will write mu k equals 0.178. I've got my car that's going to be skidding to a stop, so it's moving along at some velocity, and that initial velocity is this one up here, okay? So this meters per second is my initial velocity. I know that my final velocity is 0. I'm looking for the distance that it travels. And gee, if only I knew my acceleration, then I would be good to go. So my acceleration is what I need to find here. In order to find my acceleration, I know that F on the car is going to be the mass times the acceleration. Well, what force is going to stop the car? Turns out that it's going to be the force of friction. It's going to be the mass times acceleration. And the force of friction, one more step. I know that my force of friction is going to be mu times my normal force. Well, I've got mu. I need my normal force. For the normal force, well, that's mg. I don't have m, so we're just going to keep it as mg. So I know that my normal force is going to equal my force of gravity equals mg. So let's gather all this together. My normal force is mass times gravity. My force of friction is mu times the normal force. And that's also my mass times acceleration. So I know that mass times acceleration from here equals mu times the normal force times my normal force, but my normal force is my mass times gravity. Oh look, there's mass, there's mass. I know that my mass cancels out, so it turns that my acceleration is going to be mu times gravity. That's pretty neat. Now, how do I get velocity, final velocity, displacement, and acceleration? I know that v squared equals v0 squared plus 2ax. My final velocity is 0, and that's going to be my v0 squared plus twice my acceleration times my displacement. Knowing my acceleration is mu times gravity, that fills this in. My initial velocity is this that I figured out here before, and my distance is what I need to solve for. So using this, you can get your distance that you need to travel. What is the stopping distance when the surface is dry and the coefficient of kinetic friction is 0.519? Well, same problem, but now the mu you're going to use is going to be 0.519. So that's, you're going to recreate it, redo this problem with a 0.519 coefficient of kinetic friction. So your acceleration then will be 0.519 times the acceleration of gravity, which is 9.81. So you get your acceleration, then you got v squared is v0 squared plus 2ax. Same problem, and you're going to get another distance for the second part.